Lesson 12.4 is integrating algebraic functions with what's called u-Substitution of power functions. So what would happen if we had a function like this, and to get this all in like a power function where there's no parentheses, I would have to take this x squared plus 9 times itself 3 times, and then times the 8x. I could do that, but that takes quite a while. So there's actually a way that's faster. It's going to take a little bit at first to get used to, but then it'll get easier. And that is called u-Substitution. So that's taking the part that's making it tricky and using the letter u to replace it with, and then we'll plug what u stood for back in at the end. So I'm going to take u and set it equal to this x squared plus 9. Not the to the third power, just the inner part, what's inside the parentheses. Okay, and then I have to take the derivative of u, which is 2x, and then my constant would go away. And so what I want to do now is go ahead and take the antiderivative. I'm going to rewrite this as 8x u to the third power dx. But I don't like that there is x in here, there's dx in here when I've got du. So I actually want to take du with respect to x. So I'm going to put du over dx. And that's how I got my 2x. Okay, so now I want to have dx be du. So I'm going to solve for dx. So I said that kind of weird, but I'm going to want to solve for dx so that I can replace it and it'll have a u instead. So think of this as like a proportion where I would have 2x dx equaling du, and then I would divide away the 2x. Because my whole goal is to get a dx equals du with something. Okay, the other thing we haven't talked about, but you might have seen on the examples, is any constant you can take out because the antiderivative of that is still going to be that number. So I'm actually going to take out the 8, and then I'm going to have x u cubed, and then I'm going to replace dx with this du over 2x. Okay, I see that my x's are going to cross cancel here, which is a good thing. And then this is really like a 1/2. So then I could go ahead and say, well, I want to divide by 2 my 8 out here. And that would get rid of that too. So 8 divided by 2 is 4. And then all I have left is u cubed du. That's what I wanted, was to get the same letter here. So now I'm going to try to do my anti-differentiation. So I still got the 4. Remember, I add 1 to the power. So it'd be u to the 4th divided by 4 plus c. My 4's are going to cross cancel, and so I get u to the 4th plus c. Only thing I have left to do is I don't want to keep it u. I want to replace u with what I first assigned u to be. So I'm going to replace u with the x squared plus 9. To the 4th power, right? Because it's that getting plugged in plus c. That would be my answer. It gets better as you practice it more. Okay, let's try number 2. So I'm going to anti-derive this function. What I would do is I see what's making it complicated here is having x cubed plus 10 to the 7th power. That would not be fun to multiply this 7 times. So I'm going to let u equal x cubed plus 10. Okay, I'll rewrite this first. I'll have 6x squared divided by u to the 7th power dx. Okay, I don't like having dx here when I've got it in terms of u here. And again, this will get canceled. You'll see that happening every single time. If it doesn't, you've done something wrong. But what I want to do is I want to take the derivative of u with respect to x, and that gets 3x squared, and my constant would have a derivative of 0. And then I want to cross multiply here to solve, so I get 3x squared dx equals du. I'm trying to get dx alone, so I would divide by 3x squared. So dx equals du over 3x squared. Okay, so now I'm able to replace this. And again, I can choose to take out that 6 now or wait. It doesn't matter. I'll have 6x squared over u to the 7th times du over 3x squared. So what simplifies? My x squareds will cancel. My 6 divided by 3 will become a 2. And so now I really got 2 over u to the 7th du. So now I think I'll take my 2 out. I'll bring that u to the 7th up, so I'll make it a -7 du, and I'm ready to take the antiderivative. So I'll have 2 u to the add 1, that would be -6 divided by -6 plus c. Simplify my 2 over -6, that would be -1/3 u to the -6 plus c, and then I want to look and see what was u equaling, this x cubed plus 10, so it will get replaced right here. And that's it. So again, the u-substitution is because these are going to take too long to get everything expanded out. So the part that's in parentheses is your u. You have to differentiate it with respect to x because we have x in there, but we're wanting to replace dx with a du. Our x's will always cancel out, so that won't create a problem anymore. You can decide to take the constants out before you antiderive or wait until that something simplifies, then take it out, however you want to do it. And then do your antideriving rules and then replace your u with what your substitution was set up to be, and then always have plus c on the end. And that's it.